All right, everybody, we're going to jump into Unit 1, Lesson 8 here, which is going to be on color images. So yesterday we looked at the black and white images, right? So we were looking at the different pixels, and they could either be black or white, depending on whether our bit was turned on or off. We're going to go ahead and extend that now to color images. So we're going to continue to represent these analog images, right, which are these smooth, continuous images with digital representations. Okay, so we're using the bits to represent these analog images, and the more bits that we have, the closer our digital approximation is going to be to the original analog image, right, the perfect image that's continuous. So to start, can you just think about how many different shades of the color blue you can name, right? So you think back to when you had like box of crayons and how many different shades of blue there were there. Okay, and and then we want to think about how many of those could we represent using using these bits, right? Is there a limit to that? And of course, there's tons and tons and tons of different shades of blue, right? You could always be altering it just a teeny bit, right? And so if we wanted to represent those with bits, we would probably need an infinite amount of bits, but we can get pretty close to most shades of blue, right? If we increase the number of bits that we're using, and we're going to see how to do that here today. So just like I was saying, a quick refresher on yesterday's stuff. Yesterday when we were looking at each pixel, right, we were taking these samplings and we were looking at each pixel. The pixel either had the option of being turned on or off because it was just one bit for that pixel, right? So if it was on, it would turn to white, and if it was off, it would turn to black, right? And so you had these options of either having it as black or white because it was just one bit for each pixel. Right? And when we have just one bit, there's only two options, right? Remember, if you think back to when we first started looking at binary numbers, you have two options, either a 1 or a 0 for each bit. But if we increase the number of bits per pixel, then we can increase the colors that we're going to have, the options that we're going to have for that pixel, right? So if you think about a pixel as just a one little square, right? That's kind of what we're focusing on right now, as a pixel is just one little square. If we use three bits to represent that pixel, we have a bunch of different combinations of ones and zeros that we can make for that pixel. So we're gonna look at that today using this RGB encoding, which is red, green, and blue. Okay? And you can kind of see that they're breaking this down similarly as to what I just explained here. So if you need to pause the video and look through this, you can. But with the RGB encoding, you can see that the first bit is going to represent the red. So if you flip that one on, then it'll turn your pixel red. The second bit is going to represent green. So if you flip that one on, it'll turn your pixel green. And then the last bit will represent blue. And if you turn that pixel on, if you turn that bit on, it'll turn your pixel blue, right? And obviously we can create a bunch of different combinations, right? You could flip on the first two switches. So you could flip on the red and the green, and that would create a combination of those colors there. But the point is that we've got more bits for each single square, for each single pixel. And as we increase the number of bits, we can increase the number of colors that we're going to be able to represent for each pixel. So we'll be able to more closely represent these analog images that have color in them. At the bottom there, I want you to take note. It says with 3 bits, this means we will have 8 choices of color for each pixel, right? Because if you've got 3 bits, you can create 8 different unique combinations of ones and zeros. And if hopefully that's clear to you, right? If not, go ahead and you can jot down all the combinations using 3 bits, using 3 placeholders there, or you can write them all down, 0, 0, 0, 1, 1, 1, and everything in between there, and see that there are 8 different unique combinations. So we should be able to create 8 different colors for each pixel. Okay, so in a second, you're going to move to code.org on lesson 8, and you're going to go through bubbles 1 through 5. There should be a quick explanation for you on how this pixelation widget works with the colors there. So you can watch that, and it'll break it down for you. I want to zoom in here on this screen real quick because this is what yours is going to look like, and just explain a couple things or point out a couple things. So first, notice that we're changing the bits per pixel to 3. Right, and they'll explain that in the video, but yesterday it was just 1 bit per pixel, right? So it was either on or off, black or white. Now we've got 3 bits per pixel, and if you slide over, you can see that we're using this RGB encoding format. So that's red, green, and blue. And so those are the colors that we're going to be able to combine right now. So when they set this up, I want you to think about how they're organizing it on their screen, because I think that the organization is important so that you don't end up with mistakes. And if you do end up with a mistake when you're typing in your binary here, you can go back and quickly change it. So the first piece up here, this combination of ones and zeros, is just setting up the image width and the image height, right? You won't have to do that. It'll be auto-filled for you. Okay, you're going to start down here filling in the RGB colors. So notice that each combination of 3 bits represents 1 pixel. So the first pixel is those 3 bits combined, right? And in this case, it's 1, 0, 0, so that's just red. That's why the first pixel is red there. And then the second combination of 3 bits is the next pixel, right? And notice that they're putting a space in between so they can kind of organize where each pixel starts and stops, right? So the first pixel is these 3, then we take a space, the next pixel is those 3, and so on and so on. So if you space it like that and then you make a mistake, you can go back and find which pixel needs to be changed. So I think that's a good organizational strategy for you there. So that those 3 bits represent 1 pixel, these 3 bits represent 1 pixel, and so on and so on. All right, I'm gonna give you a few minutes to flip through levels 1 through 5. So you can pause this video. Please come back to the video when you are done with levels 1 through 5, because I want to give you a couple of pointers before you move on to the next couple of bubbles after 5. All right, go ahead and pause it. Take some time to work. Remember, you can work with each other. If you get stuck or if you're confused, lean over, see what a neighbor has going on, right? And help each other as you go through this. Okay, hopefully you've gone through levels 1 through 5, right? You're kind of getting the hang of changing the bits per pixel, right? Remember, more bits, we can get closer representation to the analog image, right? More bits is more information, okay? And you're playing with the switches, turning them on and off to create different color combinations. So what you're going to do now is you're going to pick one of these images that they've got here for you, and you're going to do your best to represent it with the binary, right? So there's a couple of layers to that as you look through it. So first, you're going to have to pick whichever image you want, right? You can select any of these here. Maybe it would be good to pick a color one, right? But whatever you're feeling, pick one of those images there. And then as you start to go through it, you'll see you're going to have to choose your sampling size, right? So, how big is your sample going to be, right? So how big, and that's going to dictate how big your pixels are, right? So the more samples that you take there, the smaller your pixels are going to be, right? And the better representation you're going to get, okay? And then after that, you're going to have to figure out how many bits per pixel do you want, right? And so, you want to pick at least 3 bits per pixel, right? You can, depending on how ambitious you're feeling, you can pick more bits per pixel, and then you'll be able to get more color combinations and probably a more exact representation of these analog images here. Okay, so pick one of those things out. And then they've got a tip for you, because when you start to recreate those images, you won't be able to see the original image anymore. So if you want to copy the tab that you're working on, you can go ahead and do what it says here. You can hover over the circle of the level that you're at the top of the screen, and then right click and choose open in a new tab. So you'll basically get 2 tabs that are exactly the same on your computer. That way you can flip back and forth between those tabs so you can see your image, and then you can work on the pixelation widget on the other screen, so that you can kind of flip back and forth and see your picture and what it should look like. So when you get to the widget there, you're going to see that's on the left side. There's this, it looks like a little cell phone, right? And the cell phone there will let you toggle through the different images, and then it'll let you create a sample size, right? That way you can kind of work pixel by pixel, and just match up each pixel as you go. And when you use the little phone that's on the left side there, right, if you want to use that phone, you have to first click where it says run at the bottom of the phone, and then you can start to select from the drop-down menus and things like that. But if you don't click run first on the little phone that's on your screen, then it won't let you select from the drop-down menus and use it properly. So you got to hit where it says run at the bottom of the phone, and then you can do that. And then open up the new tab and go onto the pixelation widget and start to create your or recreate your digital representation of that analog image. So you can see that the examples that they've given here that I've got on the screen, right? They've taken different sample sizes for their pixels. They've got a different amount of pixels for each one. Okay, so whatever, however ambitious you're feeling, hopefully you're not picking something that looks like this, right? Because that's not too many samples there, right? Those are pretty big pixels. We can probably do a little bit better than that, and then go ahead and try to recreate one of these to the best that you can. And I'll give you some time to work on that. Remember, if you get stuck or if you're confused about what you're working on here, please reach out to a neighbor. And if you both can't figure it out, you can send me a message on Remind or an email. I'm around. Okay, I'll give you some time to work on that, and then we'll come back together for the wrap up. So you can pause the video and then come back when you're ready. Okay, moving on. So hopefully you're able to get a good representation there of those analog images, using the different colors. I want to go through this wrap up here, so you can jot this down in your journal as kind of the key takeaways here. So the first thing is that the digital versions, which is what you're creating, right? These digital versions of the images we produce differ from the original analog images. So the analog images are like the originals, right? They're the ones that are continuous colors, right? And we're creating digital representations, but there's a limit to how precise we can be, or there's a limit to how exact our digital representations are going to look, because we only have a finite amount of bits that we can use, right? The more bits that we use, the closer we can get to the analog image, but there's obviously a limit, right? In reality, we can't just have an infinite amount of bits. Okay, so they're going to differ a little bit. They're just representations. Analog images change smoothly and continuously. With digital images, we are limited to the number of bits that we use. Even if we use a lot of bits, we can still only represent a finite number of colors, and gradual color changes can only happen discretely through a finite set of pixels. Right, so what they're saying is, like, when you look at one of these images, right, there's an infinite amount of color change that's happening, right, in these really tiny samples, and we can't realistically represent every single one. Okay, we can just get as close as we can with our digital approximations there. So let's think about the levels of creating these digital color images, right, as you just did. This is another example of abstraction, a word that we've been talking about, right, where we take something that's, seems simple, but it's actually more complex behind the scenes, right? There's a lot more happening than we know. So when you created these things, you can jot down these layers of abstractions and color images here in your journal. It says you have the digital image layer, right? That's the approximation that you created. But all these things had to happen before you ended up with that digital image layer, right? First, then you had the sampling layer, right? So you had to figure out, okay, what kind of a sample am I going to take here? And that determined how big your pixels were going to be, right? How many pixels you were going to have. And then once you figured out how many pixels you were going to have, you had to figure out how many bits for each pixel, right? So it's all these different layers that lead up to this digital representation. So this is an example of abstraction where we see the digital representation, but there's a lot of work that's going on behind the scenes, okay? And again, it all goes back to these ones and zeros, so the binary numbers, right? So it all starts there. And then lastly, there's a video for you to watch on code.org. I believe we've already watched this video a couple days ago, right? You can refresh through it. Maybe some of this will make more sense now. You'll be able to connect with it a little bit more than when we first watched it, because you really hadn't seen any of this in action. It was kind of just like an intro of what's to come. Right now, maybe a lot of things that they're mentioning will resonate a little bit more, right? So you can give that a watch there, and then fill out the reflection questions for this one, for this lesson 8. And when you're done with that, there is a checkpoint quizzes that you can do on Canvas. You can navigate there, right? You can use a partner, right? You can use your notes to go through it. Just do the best you can on that. See where you're at. It's kind of a couple of key points from all the lessons that we've gone through so far, to make sure that we're kind of all on the same page and we're getting the major takeaways from each lesson there. All right, reach out if you need anything. Hope to see you soon. Talk to you later.